Today what we're going to talk about are real numbers. And real numbers are all the numbers we've worked with in math and will work with in math this year. And it's just a big category, but it has a bunch of smaller categories within it. So whole numbers, this black set, are going to be the numbers that are ones like 1, 5, 3012, all of the numbers that are positive and are complete numbers that don't have like a fraction or a decimal part to them. So then we have integers. Integers are all those whole numbers and their opposites. So let's see here, if I have 0, if I have -2, 312, -75, all of those are integers. Again, no fraction parts with them. They're whole numbers and their opposites. By the way, one important thing here, I know it seems like a weird concept, but 0 is actually considered to be a whole number. So then we have rational numbers. And rational numbers I'm going to put up here. Rational numbers are any number that can be represented as a fraction. So if you remember, all of these ones here, these black and blue ones, can be represented as a fraction just over 1. So those are all rational numbers. Just like all whole numbers are also integers. But rational numbers also include fractions, like 2/3. They also include mixed numbers, like 1 and 5/8, because that can be represented as 13/8. So they also are decimals. If you have a terminating decimal like this, 0.2, that's going to be 2 divided by 10. If you remember, we also had these ones here. If I had 0.6 with a bar over it, that's going to be 6 divided by 9. So all those can be represented as fractions. So any number that is a decimal or a fraction, and a fraction that either ends or a fraction that repeats, all those are going to be rational numbers along with integers and whole numbers. Now we get to the new ones, and those are irrational numbers. And irrational numbers are ones that are square roots, primarily for this lesson. So the square root of 5, if you plug it into your calculator, you're going to see that it has no end, or at least it just ends when the calculator ends, but there's no clear pattern to it. It goes on forever. Any number here that, if I have here square root of 90, if I have here 5 square root of 2, that is an irrational number because square root of 2 is a decimal that doesn't repeat at all, and that's just going to be that times 5. So irrational numbers and rational numbers together form real numbers, this big category, real numbers. So all this is about is definitions. So one minute time I'm going to clarify this. So we've got our whole numbers. Our whole numbers are these ones here, 1, 5, 3012, 0. All those are whole numbers. Then we've got integers. Integers are all the whole numbers and their opposites. So we have 0, -2, 312, -75. Then we've got here rational numbers. And in those rational numbers, we're going to have all of the integers, because you can have negative fractions as well. So I could have -3/2. That would be a rational number also. All of the integers and all of the fractions, and then all of the decimals that either end or repeat. And then the final category here is going to be irrational numbers. And irrational numbers are ones that don't fit those other categories. They're decimals that go on forever and don't repeat. And they're primarily going to be square roots. So if we're asked to classify numbers, we're going to classify them at like 5/8. That is going to be a rational number. If I'm asked to classify the number 3, that is going to be a rational number. it is also going to be an integer, and it's also going to be a whole number. So it meets all three of those characteristics. If I have something like the square root of, let's see, a square root of 5, that is just going to be an irrational number, because when I plug it into the calculator, it goes on forever and it doesn't repeat. If I have a number like negative 12, that is going to be an integer. And it's also going to be a rational number. Rational number. So you're looking for all the categories that these fit into. One thing people sometimes get a little bit confused by is when they see a square root symbol, they automatically assume it's an irrational number. But if I have the square root of 16 over 25, that's going to be equivalent to 4 over 5. So it looks like it's irrational if you just look at this, but when you do the math and simplify it, it's going to become clearly a rational number because it can be represented as a fraction. So let's say I'm asked to compare these two numbers and say which one is bigger. So in this case here, I'm going to put the number 2 into a calculator, take the square root of it. See the negative sign in front there? It's going to be something like this, 1.41, and then a bunch more digits. 3 divided by 2, when I put it in a calculator, it's going to be 1.5. Don't forget the negative. So which is bigger, negative 1.41 or negative 1.5? This number is actually bigger because it's closer to 0. It's less negative, so therefore it is bigger. So you're just going to plug things into a calculator and put things in the correct, just figure out which one has the bigger decimal, and that's how you figure out the order of something. And this would work the same way if you had a problem like this. What you would do is you would just take the square root of 10, then do 7 divided by 3, then do 2 radical 2, 2 times radical 2. Figure out what all those are equal to. Write down the decimal equivalents underneath them, and then just compare them and put them in order from least to greatest. So I know this is a lot of vocab, but really whole numbers, the numbers 1 through a million and a billion and so on, those are the whole numbers. Then we've got integers, those are all the whole numbers and their opposites. Don't forget the whole numbers include 0. And then you've got rational numbers, those are all fractions and decimals as well, except for decimals, including decimals that repeat and decimals that end. And then you got irrational numbers, and most of those are going to be those square root things that we've got.